Okay, welcome back to the channel, guys. Tonight we will be working on this BMW. It's a 2016, I believe, BMW 750, and it has a check engine light. It does start, run, and drive, but the check engine light is actually for something related to the timing, particularly with bank 2 on the exhaust cam. Now, there's a couple different ways that we can go about trying to check out what the problem is, but one of the issues I found myself to run into as I was trying to do some research beforehand on trying to figure a path or a diagnostic approach is that this is a little bit newer with the DME, which is the engine computer, and the service information that I use 2 of them currently, and both of those do not specify what the pins are on the DME as far as whether they're signals or power supplies or whatnot for the cam sensors. I was looking to do cam crank, monitor those as we crank it, start it, so on and so forth. But right now, since I can't get that information at the moment, I think I'm going to try to approach it a different way to see if we can identify why the trouble codes are popping up. And to bring you along, get you a shot and familiar what this setup is, this is a variant of the N63. It is the V8 twin turbo, and obviously this is a later or newer style or generation that I've done videos on and or worked on. So first things first, again, I have done some that have dual DMEs, but these are the newer version DMEs also, which I personally still have not messed, and you can tell by the style of connectors and number of connectors per DME. The reason why they use 2 DMEs, basically one controls bank 1, the other controls bank 2, and that's how they operate and run the engine. And if we bring you inside, I will show you the trouble code. And actually, just to show you, let's do an auto scan. And so if we get you a shot of the report, so we've got DME 1 for bank 1, obviously. We've got some messages about battery. The car has been sitting here for a while. Interesting that it has in service requires engine oil. So in the dash, it does light up for the service being due. So I'm wondering if that's related to that. But if we go over to DME 2, if we look at this, we've got 1, 2, 3 codes. VANOS solenoid valve exhaust 2, position not reached. VANOS exhaust 2, not controllable during cold start. And then camshaft jam. Now these are intermittent, that's supposedly permanent. I was checking this and scanning it last night. But I think these were all permanent in the beginning, and I cranked it and ran it a few more times, and we have changed these to intermittent. One thing I can tell you, the vehicle starts up and runs and idles just fine, like you would not notice or get any clues that we have any type of timing problems like other manufacturers or some other BMWs that are really far off, though hard to start and idle funny. This one actually drives okay, or seems to drive okay, and idles okay. But these are codes that continue to return. It's more than one. Obviously, they're trying to tell us different things. So let's see. Position not reach, not controllable, and jammed. So some might appear due to the others, and it's just basically flags, 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 warning us, telling us that there's an issue there going on with the the VANOS, which is basically your variable cam timing on the exhaust side for bank 2. So because I can't mess around with cam and crank signals at the moment, I think I want to go ahead and take physical measurements of the engine on in-cylinder bank to bank and compare the two banks with the pressure waveform signals and see if we can find the difference. I've done this in the past. I have some videos showing that. Particularly one that comes to mind was an Audi, and it was a single code per one bank, and so I ran the same test bank to bank in cylinder, and we could definitely see an issue. As far as what I'm looking to find out is if we're gonna crank it, which I'll do crank cold start, crank no run, and I want to look at the signals, and if it's off right at just cranking, almost believing that we're going to have a phaser that's damaged, faulty, whatever, and has the cam timing at an off point. If they are the same, then we'll start it, idle it, watch it from cold start because it'll have some phasing. We want to see that the phasing is the same, bank to bank, and then we can give it a little snap throttle. We just want to watch and see if that exhaust cam moves and moves the same as the other side, and kind of go from there. Okay, so I've got the scope running. I am all set up. It took quite a bit of getting into some of these components because they are buried. But ultimately, what I've got set up, I've got all the injectors unplugged. I'm going to do crank no start measurement first of in cylinder. I've got my transducers covered with the rag because they're sitting right next to the coils. I don't want anything happening, so those are isolated coils for cylinder 1. This is bank 1. This is going to be our reference point. Is coils unplugged for cylinder 5. This is our bad bank. We want to see something here, hopefully. And I've got ignition coil trace, just to see another reference point. I was unable to hook up the relative compression, at least up front here. They made it difficult, unlike generations before. The cable runs really, really tight up against the body, and you can't get a clamp around it. So for now, I am not referencing relative compression, but again, hoping to see something in cylinder. We'll do crank no start, and I'll actually have you guys on the scope, I think, and watch and see what that looks like. Okay, so here we have the capture of the crank no start during the cold engine, the one we just saw. So the main thing, again, of doing this cranking test with in cylinder and comparing bank to bank is that you want to take a look physically at how the engine is basically producing its in cylinder pressures, and it can only do that by the way it's gonna move air, meaning the way it's going to breathe air in and move it out, and all related to obviously also the timing of it. And so for starters, let's see, if we just off the bat now, looks like I believe the gold trace was bank 1 and the purple is bank 2, our suspect bank. Off the bat, you can tell that there are some differences. Again, you're using this for a comparison at just cranking. You gotta remember that we are just cranking. Nothing else is involved. We're looking at the engine, how it's moving air. And so if we take a look at the bottom section, which is where we are more interested in, these peaks obviously are different levels, but the bigger portion that you want to look at for comparison is this portion here. Now, if you're not familiar with in-cylinder pressure readings, the big peaks or towers are your compression humps, and at top dead center, so as it's traveling upwards with the valves closed, it's going to create a lot of pressure. That's why these voltage levels go up, and then it'll come down. This is where the exhaust valve will open at some point at bottom dead center, and then you have your exhaust stroke, and then your intake stroke, and then your valve closes again for going towards top dead center. The area of interest where we are having a difference between both banks is in the exhaust pocket, to the point where the exhaust valve opening occurs. If we go ahead and use this to get some measurements, let's go off of the known good first. We're going to take a look and see, just to compare, because we can compare, when the exhaust valve is opening on the known good bank, and then compare that in the same way and fashion to the bank at question, which we clearly obviously do have a difference. So we'll go down here. We've got our ruler set, and so we'll take this measurement of, okay, I would say probably around there. Let's see, and we don't have to nitpick it, but so that is telling us basically 64 degrees. Right there. So 64 degrees before bottom dead center is when that pressure changed. That is when the exhaust valve opened. Now we'll do the same for the bank 2. We have to move these over. Okay, so we've got those main rulers marked properly, and we will take the degree measurement. And that looks like a good point. Again, we are measuring that area. That change of direction in pressure is when exhaust valve open, and this one is at basically 57. So that is telling us what, about 7 or so degrees difference of when the exhaust valve is opening bank to bank. Now obviously they should be the same, but they're not. We are, looks like, retarded about that 7 degrees on this bank 2, which would make sense why this travels further down, because it takes longer for the valve to open, as you can see there. So exhaust valve open sooner on bank 1, which is why we don't get the further travel. But this one, since it's delayed, we get to still travel further, because this whole section in our 4 sections here, our strokes, we are traveling downward with the piston, and that is when the pressure got relieved. Same there, but this one again got to travel further down because the exhaust valve opened later. So we are breathing differently in that exhaust valve area. But we know it's not, I'm going to call it a timing issue, or a correlation exact type issue, because our DME is not reporting, and we're not, I know this is used to also check timing, but we have to also understand what comes into play with what's going to show us valve timing events. And here we do have a variable phaser that I believe is what's causing this. the other notion. Again, just experience with BMW. They are very, very good at nitpicking any type of correlation issues. And the way this cranks starts idle, there's no extended crank, there's no trouble codes for timing. You can drive it all day and not have any drivability type of timing issues. So I know it can look like timing, but I don't believe it's a correlation timing issue. That there is a breathing difference, but I think we are possibly looking at a phaser issue. And to try to maybe prove out the point, I'm going to take some further measurements and compare them to bank 1. Obviously, we've got an exhaust measurement there. So right now, we're just going to measure this point, which it's telling us 50, let's call it 58 degrees. And then we'll go ahead and measure that point. And now we've got a measurement here of when the intake valve closes. And let's call that 20 degrees. So all that is for bank 2. And now that we moved our rulers over to correlate correctly with bank 1, let's take those same measurements. We'll do them in the same order. Okay, so that's 57. Our last one was 58, so that's pretty much dead on. And then let's do the other measurement. So right there. And we're at 20. So, okay, so those two pretty much match up. So those are the further measurements. And that, again, equates to timing being correct. But just the difference there is a breathing issue of being affected by something that's not timing. And to maybe explain the difference here of levels, taking this measurement over here, so that is where it looks like possibly exhaust valve closed, right there. So it's before the top dead center portion, and we are getting about 12 or almost 13 degrees, let's call it, somewhere in that range. And let's go ahead and compare that to the other bank. And so now that we've got, again, our ruler set well. Okay, so somewhere in that region. So we are 8.5. Okay, so again, we are a number of degrees out in difference, all related to the exhaust area and play of possibly the cam phaser. But the result of this difference here is basically what we're seeing is an end result of the effect of what happened prior. So this one, because it's more advanced, the events are happening more advanced, this started to go down sooner and then got further at the same opening point, because our valve timing is the same, but this one started going down later, but in timing event the intake valve is opening the same time, but since this started later, it didn't get to reach that point when that intake valve opened at the same time compared bank to bank. This got to travel further because this closed and rose up and started going down sooner than this bank. Okay, so now I'm gonna set it up to start, idle, and run, and I want to see what that looks like, particularly on the exhaust area. But I've got injectors all plugged in. The air box is kind of just settled in there. It might run a little bit rough because air path is not as direct, but it should be good enough. I've done this in the past, so let's get it cranking, running, idling, and get a good waveform and see what that's going to look like. Now, I didn't show you this before, but let me show you. Obviously, we're going to have multiple codes now for the testing that we've been doing. But, so let's see. The 3 VANOS ones, you can look at some information as far as descriptions and, possible causes and whatnot. So, let's see. So as far as this one, the camshaft jammed, it's telling us that the fault is entered when the VANOS solenoid valve is jammed at an incorrect position. And then here at the bottom, it tells you possibilities. Obviously, oil pressure is going to be oil level and pressure, stuff like that. Let's see. And then it tells you to start checking some of the VANOS components and kind of go from there. And if we look at, let's see, position not reached code, entered when adjustment is too slow. Okay, let's see. And then it's the same description down there. And let's see for this one. Not controllable during cold start. So it's telling us that during the cold start and warm-up phase, it's entered when camshaft cannot be adjusted to a set point. Now I think we're sort of seeing this. Let's see, not controllable during cold start. I'm wondering if this is the one that's triggering the other codes, just from what we are seeing in the scope capture. And this actually has a little bit, I think, different description, maybe. And so that's the description, again, as we have been seeing with the other 2 codes. Now, let's see. If we, as far as with this tooling, there is no testing of the VANOS system in active test. Now we are in DME 2, and out of curiosity, we can check DME 1, active test, and again, nothing for testing the VANOS system. If we back out, I'm wondering if we can find it under service. Let's see, powertrain. So it looks like we don't have anything for VANOS. There's stuff for Valvetronic. I wonder what that is. Okay, so we actually got something in there. Let's see what that does. Let's see. F7. Okay, let's try running the engine. hard to tell there since we can't graph it. That's weird. Intakes seem to be off more than the exhaust. Okay, not sure if that's going to be helpful or not. So let me see what to do next. Okay, and so the capture that we've got here in front of us is clearly our start, run, and idle of both in cylinders with ignitions. But again, we are going to pay attention at the in cylinders, particularly down there. Now, when we're starting it and running it, we are now introducing additional factors to the engine, the way it's running, meaning we are increasing our RPMs. Our breathing is going to be a little bit different, and also we are having oil pressure come into play. And lastly, the DME is now attempting and attributing some cam phasing, particularly in the exhaust side, and we will get to see that. But this here is also where on the last video I mentioned on the Audi is where I saw a difference. Yes, we clearly see and saw a difference cranking, so that should not be there. There should not be a difference bank to bank. But what I think is going on, that possibly the phaser's not locked when it's off with no oil pressure, which is why we saw the difference in breathing while cranking no run. And so we'll take a look at the area where this will basically put the dagger in the coffin. Now remember, this is all due to what we believe is occurring during the startup, the start, run, and idle. So what we want to look at, obviously here is the beginning portion of when we first cranked, and then we get going. So let's just keep an eye there in the lower portion at the pressures and pressure levels bank to bank. So that hopefully is a good picture. Let's see. So again, purple is bank 2, yellow is our reference, and I'm just simply going to scroll over as we get the engine going in time. And if you notice, so peaks are kind of, you know, similar, not the same, not the same. I'd say it's still a little bit not the same, and then finally start to sort of look the same. So we are having almost, let's call it, bouncing, like the gear maybe's rocking, and not able to fully, let's say, control it as to how the DME would want it and is expecting by, obviously, the only way it knows that it could be off is by watching the exhaust cam sensor, which, again, the whole purpose of me going in cylinder is because I don't have access to that information of the wire pinouts at DME, blah, blah, blah. So this is another way that I used and am using to physically look at the pressures to verify what the problem is. And it's clear as day that we, even this cycle back to this one, this should not happen with the difference in pressures. When you look at the good bank, it's consistent until this point is where the phasing starts to happen, and that's when it's moving the exhaust cam, because in that gold trace, the one in the back, is occurring, and then it's changing and changes for the good, let's call it. The purple is just, it's supposed to go through the same, basically, operation, but here it was different from there and back to where it was, which shouldn't have happened, and then starts going to a different direction. So that right there is 100%, again, undeniable data that we're physically seeing and occurring, and we're capturing it, and should not be happening. And just lastly, just to again show you another example, here we clearly have two cranking start idle events back to back, and so let's just look at what we have here. We'll do the same thing. We'll just scroll over and look at our pressures, and again, boom, right there. So about the same, changes back up, and then starts going back down. So we have that same pattern, same issue going on with pressure reading difference bank to bank, and that is our first cranking event. Let's go to the next one. Again, this is after we shut off, oil pressure goes down, oil drains, and then we'll start back up, build oil pressure, and let's see if we have, and again, right there, the difference in pressure. Now, you could argue only last thing that could affect something of the phaser is the solenoid valve, and or the basically the oil control valve in the solenoid valve basically actuates. But I'll get you a shot of what that looks like here in a bit. And lastly, just to show as to possibly why it does, start up fine, no extended crank, and randomly we'll get that trouble code. We know and see that here now, but on the continuation, if we just continue, pressures, they basically match up. They look the same, even up top. No crazy drastic difference. Again, we just scroll. There's no bounce back, no spikes. Basically, after it's phased, after it's controlled to phase, it seems to move in a correct place, and it's running basically a good comparable pressure reading to the known good bank. Again, this is after it's changing its idle, but it's doing the same bank to bank. So there you go. That kind of shows us the whole story and where we are generating our trouble code and why it runs the way it runs or how it runs. Okay guys, so clearly, as you can tell, we have gone ahead and opened this up, taken it apart. We've gotten down to where we can eyeball the phaser and the cam and so on and so forth. Again, this is going to be the side and cam that we are concentrating on. I've removed this one for basically timing, checking on that bank. But now thinking about it, I probably, with what we are going to do, probably didn't even need to take that apart, but that's neither here or there. It's just gonna secure me knowing both banks are gonna be straight up. So what am I talking about? Basically, we ended up last in the diagnosis part, seeing movement in the exhaust area of the in-cylinder waveform. For this bank, we were in cylinder 5, whereas we were seeing that difference, and we were gonna attribute it to the variable timing system, basically kind of in line with trouble codes of not being able to be controlled, or on cold start, not acting right. Basically, the computer was able to see that there was some movement that it didn't like, or not enough movement that it didn't like, one way or the other, but it was complaining here. My big thing was to try to determine if we needed to go in this deep to do some heavy engine work. That was the whole purpose of doing the scoping, and being that we physically saw a breathing difference, then that is enough evidence there. The only other factor that could have affected this was a possible sticking magnet actuator, we'll call it, which, if this does not act right, it can make the cam not move right. But upon disassembly and inspecting it, and it's not foolproof, but just from experience, if you've got sludge and whatnot, this little pintle in the middle won't move properly. Now, if you can tell, they're all in the same position right now, and let's see, there, freely on its own, it's moving. Now that's the intake for the bad bank. This is the exhaust, the one that's having the trouble code. There you go. Now, with its own weight, it is able to move and travel, and it's not a sticking valve. Yes, it could be electrical, but the way that the pattern is happening, it's consistent and always. I'm not going to attribute it to a solenoid magnet deal. The last thing to potentially give issues on controlling the cam movement is the actual phaser. So I have done one in the past. I actually have filmed how I diagnosed that one. That one was due to basically correlation codes, meaning that it had a timing problem all the time, and it would barely even start and run, if it would even start and run. That one was a actual timing correlation code. This one starts, runs, drives, and we get a cam control code, basically VANOS, variable timing situation. It's very important to pay attention to, again, as I always try to stress, the description of the code. Don't worry so much about the actual number or P codes or memorize that. That's not important. Look at the description of what the code is telling you. This one is not a correlation code. This one is a cam control code, basically. But both that situation beforehand that threw the timing off, and this one that is not controlling the variable timing, are both due to a faulty phaser. Now, what am I talking about, or how can I tell? That last one, the timing was just way off, and this sealing cap, I'll call it, was actually kind of pushed off. There's a heavy-duty spring in there that had come apart, and it wasn't able to have the cam in the correct spot, so that cam had moved. Okay, guys, so that's pretty much it. Now, the only thing that I want to bring up and or explain is that I do not have any after captures after basically the phaser, which I still have here. So here's the old one. After this was replaced. And the only reason why, and I'm filming this afterwards, but it's that was a few days or the week just before ASTE training, which we ended up going to. Now we drive there, and we do have a shop here. We're trying to run a shop, so on and so forth, in a business. But leading up to that point, we've had this car here for a while. We were trying to squeeze it and get it done, along with two other big jobs that we were needing to get done before leaving. Now you can tell by the procedure of when it was all apart. This job is huge. It's a big job. Takes a lot of time, along with everything else that you have going on. What I'm getting at is we thrashed to get this car done. We didn't do it to the point where things were left loose. No, we did it good, correct, and proper, but I just did not have the time to set up, rescope, film it, analyze, capture, so on and so forth, because we were on a crunch deadline, and along with the other cars. So I am your number one believer of after captures, to scope it, to prove out, so on and so forth. But unfortunately, this time around, forgive me, I didn't have any time to do that. The only thing that I have is my trust me with the word of mouth that after that was replaced, everything was done proper. The timing was set proper. Everything was torqued. We changed the oil to the correct oil, correct level and amount. I reset all the adaptations, even the timing adaptations, your fueling adaptations, cleared everything. And then there was multiple starts, crank, start, idle. I drove it for about 30-40 miles. Now that does eat up time also, but I needed to do that. And then not also all that, I personally drove it, delivered it to the customer's car lot. And that whole time, no lights, no issues, no nothing. So just take my word, please, hopefully, that after replacing the phaser, no codes have returned or any issues arise. But again, we physically captured breathing differences. It wasn't a timing correlation issue. The cams lined up right. It's just the phasing control that the DME was having error codes with. So with that, I hope you got something out of it. I hope the captures made sense and that you learned something. Again, we were kind of with our hands behind our back because we didn't have any DME and pinout information to do cam crank correlations, watch the cam sensors, so on and so forth. But I think this is a better alternative, and we ended up basically just physically taking pressure measurements and not finding anything through a scanner or through the other cam crank waveform. So again, I hope you enjoyed it, and that is all on this one.